Welcome back to the Bazaar of Numbers. Today, our friend Rohan is inside the main robotic assembly workshop, facing a brand new engineering problem. His teacher assigned him something heavier than usual. Instead of sorting single mathematical terms, he needs to take two completely separate algebraic structures and combine them into one. Let's look at the master blueprint. We have one structure of 3x plus 4y and a second of 5x plus 2y waiting to be added. To add them, first unpack the boxes, drop the brackets, and lay all terms out in one continuous sequence. It looks chaotic, but don't panic. Remember the golden rule of algebra from the last episode. Different families cannot mix. Apples stay with apples, and x's stay with x's. Approaching this massive expression doesn't require doing complex math right away. It's simply a matter of identifying matching parts and grouping them by their shared identities. Watch the sorting arms go to work in a process called collecting like terms. They grab the 3x and 5x, sliding them together since both belong to the blue x family. Next, they slide the 4y and 2y together because they share the orange y family identity. Now we focus on the coefficients. For the blue x family, 3 plus 5 gives us exactly 8x. We do the same for the y family. 4 plus 2 gives us exactly 6y, resulting in the finished two-term expression, 8x plus 6y. See how clean that is? We took two massive, unwieldy expressions, sorted the families, and locked together a final answer. This is your safe baseline for addition. You unpack the terms, sort them by their variable identity, and combine the coefficients. Danger! The factory alerts are going off because we have just hit a new obstacle on the assembly line, subtraction. Look at this specific setup. 7x plus 5y minus 2x plus 3y. This is the most common trap in K-12 algebra because we are subtracting the entire second expression from the first. When a minus sign sits right outside a bracket, it acts as an inverse mirror. Before you are allowed to remove those parentheses, that minus sign must fly inside and reverse the sign of every single term living inside it. Watch closely. The 2x inside the bracket was a positive number. The minus sign strikes it and turns it into a negative 2x. The 3y was also positive, but the minus sign strikes it too, transforming it into a negative 3y. Now we can safely open the gates and look at our flat line. Notice how the first expression stayed exactly the same, but the second expression completely flipped its signs. Defeating this subtraction anomaly simply requires pausing to flip the signs before you are allowed to return to the baseline of sorting. With the trap cleared, we resume sorting. We group our x family, pulling 7x and negative 2x together. Then we pull 5y and negative 3y into their own group. 7 minus 2 leaves 5x. 5 minus 3 leaves 2y. Out comes our final engineered answer. You officially have the vigilance of a math detective. You know how to group your variables, and more importantly, you know how to dodge the subtraction trap that often leads to errors on exams. But before the factory shuts down its assembly lines for the day, the grand mathematician has left one final challenge waiting on the chalkboard. The final expression on the board is 9x plus 8y minus 4x plus 3y. Apply the inverse mirror rule, flip the signs, sort your families, and drop your final simplified expression in the comments below. Keep practicing your engineering skills on the assembly line, and we'll see you in the next episode of Textbook Toonz.